Hi everyone, this video is for the revisit of quiz 3. The statistics for quiz 3 is as follows. Basically, there are 65 students who get full score of the quiz 3. And then the average score is 96.9. There are 9 people who get a score of 90 to 99, and 1 people get 80 to 89, and below 79 there are 5 people. And what is the mistakes made for this quiz 3? As you can see that the questions was selected from our homework problems, so most of the students did quite well, but there are a few small mistakes. The first mistake, which is the most common mistake, is the sign used for the question 1 when computing the determinant. So basically there's a plus minus the checkerboard pattern for the cofactor expansion in the process of cofactor expansion, the process of computation of determinant. And you need to alternate the plus and minus signs in the computation of determinant. If you continually use plus, then you will not get the correct answer for determinant. And the second one is that for the question 3, it is required to expand what you find of that area of determinants. And then some students lost a few points because they only compute the area of that parallelogram, but did not provide some reasons or explanations in that graphical solutions. And also as a reminder that next time we're going to have our midterm exam. And here are some tips for the midterm preparation. You should review your lecture slides and homework problems. And the midterm exams are going to contain questions from lecture slides, from homework. And this time I'm going to select a few, but not too many questions that are new to you. And my second tip is that you should take your own note, because as a learner, in the process of learning, students may not have the same issues. Like some may have troubles here, and then some students may have troubles in a different place. So take your own note, like remind yourself where's your mistakes that are commonly made. For example, if you constantly make mistakes in the process of Gaussian elimination, you should take notes, like have a tip for yourself, like try to remember the mistakes that you made last time, and then avoid mistakes in what way, and then so that's importance of your own note. And then also, in order to fully understand the questions, of course, that for the questions that appears in the lectures and in the lecture slides and in the homework are the questions you have seen before, and then you probably have already had a chance to discuss it with your study group. But then if you see a new problems, and the problems ask you something that relates to terminology 专有名词, then you need to make sure that you still remember what's the meaning and what's the definition of that terminology. And the third tip is that make sure to sleep early before the midterm exam, and then also eat nutritious food such as fish. And it's also important because in the process of taking exam, you need to make sure yourself be focused, and then otherwise you may make small mistakes, and that will cause a few unnecessary loss of points. Right, so in general, that the class still did well in this quiz 3, so I'm going to quickly revisit those questions. The first questions, we're going to compute the determinant for this one, but the question asks us to use the method of row reduction. Method of row reduction and cofactor expansion means that both methods can be used, but it's not required that you really have to use both of them. Of course, you can just use the cofactor expansion without any row reductions, and then, for example, if you do it along the first column and then with the cofactor expansion, it may be equals to 2 times a 3 by 3 matrix right here. And then minus 4. And here, recall that the sign is plus minus plus minus. So I have minus 4 times the 3 by 3 sub matrix 5, 4, 1, 2, 7, 7, 0. And this 3 by 3 matrix was obtained by crossing out this and this row and this column. Okay, and then for the third cofactor, it's equivalent to plus 6, and then the 3 by 3 factor was obtained by eliminating the row and the column, and then copying the values, and 7, 7, 0, and then plus a minus 6, and then the 3 by 3 sub matrix is obtained by 4, 5, 4, 1, 7, 6, 2, 2, minus 2, minus 4, and 0. Okay, that's something that you can definitely do. And then you should continue to do the cofactor expansion. Since this is a 3 by 3 matrix, so you're going to do the cofactor expansion again. Alternatively, you can also choose to do the method of row reduction. That is, you use the Gaussian elimination process to reduce it to echelon form. And then in the process, there are some row operations being used. And recall that the row operations may or may not change the value of determinant. For example, the row replacement does not change the determinant. And I put this review here because that's the main row operation used in the process of reducing this to a simpler matrix. And if a multiple of one row of A is added to another row to produce a matrix A, that is a matrix B, that is B matrix is the result of row replacement of matrix A, then the determinant of B equals to determinant of A. And for cofactor expansion, here's a review. The plus or minus sign in the ij cofactor will depend on the position of the factor in the front. And this cofactor, this signs follow a checkerboard pattern of the signs. So I have demonstrated that the signs of cofactor expansion should follows a plus minus plus patterns. And then if I go along the row, then the patterns will be a plus minus plus as well. And yeah, so that's the common mistake made in this specific quiz. So what is the suggested solution for this question 1? Actually, this is a very technical solution because in this process, the solution uses both the row replacement and the cofactor expansion in order to find the value of the determinant. But of course, you can continue to use the cofactor expansion, like to expand this 3 by 3. There are 4, 1, 2, 3, 4 3 by 3 matrices, and then you can compute the determinant of them separately. Or you can like go ahead and then reduce the matrix to echelon form, and then use the method of row reduction all the time. And either one will work, but then takes more time. So the suggested solution is a very efficient way because it takes the advantage of both row replacement and the cofactor expansion. So here's the suggestion. We use a row replacement to create zeros in the fourth columns. Okay, how is that possible? So, okay, in the original problems, there are already 2 zeros in the fourth columns. So the trick play here is that I only do one row replacement. That is to multiply the first row by -2 and then add it to the second row, and thus make the second row started with a 0 value, and then also the fourth column, the first column, second row is also at 0. So right now the fourth column has 3 zeros right here. Then I can do a cofactor expansion along with this direction. So what are the signs correspond to this uh, to this uh, to this cofactor expansion? So remember that I have a checkerboard pattern, so it's plus minus plus minus minus plus minus plus, and then plus minus plus minus, and then this is a minus plus minus plus. So therefore, in front of 1, the sign is a minus, right? And then the 3 by 3 matrix was obtained by crossing out, eliminating the column and the row. Okay, and the 3 by 3 matrix becomes this one. Okay, and then so this is the cofactor expansion that we made as a suggested solution. And the remaining cofactors involve 0 times 3 by 3 matrix, so we don't care the other 0 terms. And in order to solve for this 3 by 3 matrix, we can do a row replacements to create 0 in the first columns. And the trick is to multiply the second row by 1 and then add to the third row, and that will eliminate the values in the third row, first column. Okay, make the third row 0, 5, 3. And then I continue to do the cofactor expansion following the pattern plus, minus, plus, since following the first column of this 3 by 3 matrix. So the -1, this one is still there. But then for this 3 by 3 matrix, I have 0 times the 2 by 2 matrix determinant. I don't care about that. And I have -6 times the 2 by 2 matrix formed by crossing out the second row and the first column. So the 2 by 2 matrix becomes -3, -2, 5, and 3. And the last term, the factor, is 0. I don't care that term either. So eventually I can compute the 2 by 2 determinant, 2 by 2 matrix determinant as 3 times minus 3 subtract 5 times minus 2. So that's 1. So I multiply these three things together and get a 6. So this is a time saving process, but we are not required to really follow this process. Of course, if you follow this process, it will save your time in the quiz. But of course, our quiz has a 50 minutes 15 minutes for you to do the problem. So you definitely have the time to follow this like a brutal way to compute all the determinant of 3 by 3 matrix. But just be careful about the signs. Okay, let's review that the sign. Basically, you need to put the plus and minus in an alternate sequence. So for the first column, it's always start with plus and then minus plus. And then next to the plus sign, it should always be a negative sign. So I have for the second row, it start with negative and then plus and then minus. And then for the third column, it start with a plus and then plus minus plus. For the fourth column, it start with a minus and then plus minus. Okay, it's a checkerboard 棋盘。Right, for question 2, use Cramer's rule to compute the solution of the systems. So let's review what is a Cramer's rule. This is to compute ax equals to b. Ax equals to this lowercase b. Basically, this is the case where A matrix is 5, 2, 7, 4, and then B vector is 3, 1. And the Cramer's rule says that I need to call B subscript J as a matrix of the form that the J's column is replaced by B vector. Then xj can be computed as the determinant of bj matrix divided by determinant of A matrix. So, okay, A matrix is this one, B vector is this one. I have, okay, the solution is put at A1, or it's actually B1, same thing, B2. Is replace, I use B vector 3, 1 to replace the first column. First column is replaced by 3, 1. So that becomes 3, 1, 7, 4. That's my first B1 matrix. And for B2 matrix, I replace my second column by 3, 1. And the first column remains 5, 2. So 5, 2, 3, 1 is my B2 matrix. I compute x1 as the determinant of B1, or this A1 of B, divided by determinant of A. And then x2 equals to determinant of this B2 or A2 of B. That's just a difference of notation, divided by determinant of A. So to compute the determinant of this matrix 3, 1, 7, 4, I have 3 times 4, subtract 7 times 1. So that's 5 right here. And for B2 matrix, I have the determinant computed as 5 times 1, subtract 2 times 3. So that's minus 1. And for A matrix itself, the determinant of it is 5 times 4, subtract 2 times 7. So that's 6. So eventually I can compute x1 as 5 over 6 and x2 equals to minus 1 over 6. And that will be the solution of ax equals to b. And question 3, we have a vector AB and then another vector C0, where A, B, C are positive numbers. So I can compute AB right here. And then C0, doesn't matter, C is where. But then 0, the second dimension 0 means that it's on the axis, the x-axis, okay? And compute the area of parallelogram determined by u plus v, and 0. So basically, we're computing the area formed by here. So basically, we need to be familiar with what is the area and volume of a parallel pipe. We say that the absolute value of the determinant A, and take the absolute value of it, is the volume of the parallel pipe, volume or area of the parallel pipe, formed by columns of A. And this will be the same with the volume of the parallel pipe formed by the rows of A. And the volume is a word for three-dimensional parallel pipe, but for two-dimensional parallel pipe, it becomes an area. 就是三维的平行六面体我们是用determinant 的绝对值来计算它的体积。那如果是二维的平行四边形，那我们就是用determinant 的绝对值来算它的面积。那为什么它的 rows 就说为什么它的那个volume of parallel pipe formed by columns of A will be equal to the volume of parallel pipe formed by the rows of A? How can I exchange the rows of the rows of columns and the rows? That is because of this property. If A is a square matrix, then determinant of A transpose will actually be the same with determinant of A. So it doesn't matter whether we use the columns or the rows of a matrix to compute the area or volume of such a parallel pipe. Okay, so here's the solution, and so we can further compute. Okay, determinant of a matrix formed by U and V, that is A, B, C, and 0. Okay, so this is the determinant of it. So it's a 2 by 2 matrix. So the determinant is A times 0 subtracts B times C. So that's minus B, C. And the area equals to the absolute value of this determinant. So that becomes BC. So now you see the importance of taking absolute value. And then we still need to somehow explain it, because the questions ask us to draw a picture and explain what you find. So we need to answer both. First one is draw a picture, and second is explain what you find. So basically, we need to answer that the determinant of the matrix defines the size of the parallelogram. Okay, the determinant of the matrix, whose columns are those vectors which defines the size of parallelogram, will be equal to the area of the parallelogram, or equal to the negative of the area of the parallelogram. Or you can put that the absolute value of determinants equals to the area of this parallelogram. Question 4. Find the determinants by row reduction to echelon form. So this question is straightforward. We are asked to do the row reductions to make this matrix echelon form, and then use the properties of determinants to compute the determinant of this 4x4 matrix. Review the row operations and determinant. We have seen in the question 1 that if a row replacement is done and the new matrix B has the same determinant with the original matrix A, But for other two row operations for interchange, if two rows of A are interchanged to produce matrix B, then the determinant of B will be equal to -1 times determinant of A. For scaling, if one row of A is multiplied by K constant to produce matrix A, then determinant of B equals to K times determinant of A. And what else do we know? The reason that we can use the row reductions to an echelon form and then compute the determinants easily is because of this one. Upper or lower triangular matrix. So for an echelon form, it belongs to this class of matrix. It's an upper triangular. All the values here are 0. Or if it's an upper triangular, all the values here are zeros. Then the determinants of such a triangular matrix can be computed easily as the products of the diagonal entries. So that's why we are interested in finding the echelon form, right? Echelon form belongs in is usually a upper triangular matrix. So the determinants of echelon form is easy to find. And also we need to notice that in the process of doing Gaussian elimination, we may observe that two rows of A being equal, two rows of some intermediate matrix being equal, then we can immediately jump to conclusion that the determinant of matrix is 0. Or if we observe that a matrix A has a row being all zeros, in this case the determinant of A is also 0. What about that a matrix A has a column being all zeros? Then the determinant of A is also 0, since that we have seen that the determinant of A transpose will be equal to determinant of A when A is a square matrix. So that properties can be used freely in this process as well. But for this specific question, we only need these properties mentioned here. 3 of the possible row operations, and these two possibilities that determinants being 0, and for the computation of triangular matrices determinants. Okay, so for the process of Gaussian elimination, we first select this one as my pivot, and then reduce the values below it to 0, and then I continually select my second pivot and reduce the values below it as 0, and then I select my third pivot, and after row replacement, I identify rows being all 0, so I can determine that the determinant of such a matrix, I call it A4, for example. Well, actually, this is an echelon form. The determinant of echelon form is immediately 0. Okay, so the answer of the determinant of A will be 0 as well. Okay, and so that's for quiz 3. I hope you can prepare your midterm well and also did well in the midterm, and I'll see you next week.